students of class 12th. How are you all? Don't worry, slowly you can understand each and every subtopics of this chapter and even also the other chapters. So don't worry, just you have to watch each and every video properly and try to understand the things by reading also. Okay. So now in the next chapter, electrochemistry, which I have already started in my previous video. Oxidizing and reducing agent is the topic now. Oxidizing and reducing. Oxidation means what? Which loses electrons, and the portion or the cell or the elements or compounds which accept this electron is reduced. Now agent who itself oxidize reduce other, and who reduce itself oxidize other. So in the chart you can see here F2 plus 2 electron converts into 2F minus. That means it takes electron and reduces. And H plus ion also takes electron, reduces. Lithium takes electrons, reduces. Strongest reducing agent is lithium. And as we move upward direction, strength of oxidizing agent increases. Here, the greater the difference between the two elements, greater the voltage of the cell. That means EMF is different. As the electromotive force or E cell difference is more or greater, more voltage produced by the cell. That means what? Suppose you will take copper and zinc. Copper 0.34 is the E cell of copper, and minus 0.76 is for zinc. That means what? Copper reduce and zinc here oxidize. So you can see the difference is very much high. Hence voltage produced by the cell is 1.10. Why? E cathode minus E anode plus 34 minus 0.76. That's why it added, numbers are added here, and 1.10 volt is produced. Electromotive force means what? As I terms this. Electromotive force, the potential difference between the anode and cathode in a cell, is called the electromotive force. Potential difference between the anode and cathode in a cell is called the electromotive force. It is also called the cell potential, and it is designated as E cell. E in capital letter, and then as a subscript you can write cell. Next is standard cell potential. The cell potential at standard conditions can be found through this equation. Cell total E cell or standard of cell potential, E naught cell is equal to E naught cathode minus E naught anode. RED means reduction. Because cell potential is based on the potential energy per unit of charge, it is an intensive property. Extensive and intensive properties are the two types of properties. You know that. Intensive properties are those which depends on the nature of the cell. So E naught cell is equal to E naught cathode minus E naught anode. Therefore, cell potential or E cell for the oxidation in the cell, same zinc and copper example is here taken. The E naught 0.76 volt, and for reduction it is plus. In reduction, always remember that whenever any elements reduced, ions reduced into atoms, then it is taken in positive sign, with positive sign, and for oxidizing or oxidation we will take in minus, with minus sign, the value of E cell. So oxidation cell of zinc 0.76 minus 0.76 volt, and for E cell reduction is plus 0.34 volt. Hence total cell difference is here, or cell potential is here 1.10 volt. As it is written here, you can understand better. Twice I have explained this. Okay students, so this is cell potential. Now voltaic cell, galvanic cell or voltaic cell. In spontaneous oxidation and reduction or redox reactions takes place, electrons are transferred and energy is released. That means chemical, you will take chemical compounds or chemical energy, and through which electric current is produced, that is type of voltaic cell. Here example is given, copper sulfate solution is taken, and zinc, copper loses electron, zinc loses electron and copper will take this. So the reaction continues in this cell, or current is produced through this. Again, which I have explained, that is given here. You can see this is type of typical cell. You can see here also one salt bridge is connected, which is gelatinous potassium nitrate or sodium nitrate. Inside the U tube or in salt bridge is there, which allows to positive and negative charges transfer from one side to another. Therefore, we use a salt bridge, which I have explained you. The cell, then electrons leave the anode and flow through the wire to the cathode. As the electrons leave the anode, the cations formed dissolve into the solution in the anode compartment. As the electrons reach the cathode, cations in the cathode are attracted to the now negative cathode. The electrons are taken by the cations and neutral matter is deposited on the cathode. So students, I think up to this portion of the voltaic cell you can understand better. In my next video, I will explain Nernst equation. Thank you.